Precalculus, Module 7, Investigation 2, Angle Measure in Context. Given that the following angle measure theta is 0.45 radians, determine the length of each arc cut off by the angle. Consider the circles to have radius lengths of 2 inches, 2.4 inches, and 2.9 inches. So first, let's think about the first case of the angle theta has a measure of 0.45 radians and we have a radius of length 2 inches. So I just want to take a second and think about what that means. 0.45 radians here is the measure of the openness, the angle measure, this angle theta. And let's just think about 2 inches. So this radius length here is 2 inches. We really need to go back to what a radian means to solve this question. What is a radian? Recall from Investigation 1, a radian is a unit of angle measure where 1 radian corresponds to an angle that cuts off or subtends an arc length equal to the radius of the corresponding circle centered at the vertex of that angle. So if we had a circle and we had 1 radian as our angle measure, then that would mean that whatever radius we had here, the same radius would be here. So the way I look at this arc here, let's look at this one here. If this is 2 inches here, that's my radius, and theta is 0.45, that means that this arc length is 45% of 2, or just 0.45 times 2 inches, which is 0.90 inches. We could solve each of these other ones the same way. 0.45 times 2.4 inches and 0.45 times 2.9 inches. Notice that as the radius increases in length, because the radius goes from say 2 inches to 2.4 inches, then the arc length also increases. So each of these arc lengths, they're getting progressively larger as the radius of the circle gets larger. But because this angle theta is 0.45, it just means that these arc lengths are going to be 45% of the radius, because a radian is a unit of angle measure where 1 radian corresponds to an angle that cuts off basically 1 radius. So 0.45 radians means that the angle cuts off 0.45 of the radius, 45%. Consider any circle that is centered at the vertex of an angle with measure of theta radians. Define a formula that relates the arc length measured in inches cut off by the angle, the measure of the angle, and the radius of the circle measured in inches. Justify your formula. Just note in the previous problem, if we called the arc length S, so we have an angle theta, a radius, and an arc length S. Notice what we multiplied here in each of these cases. We took the angle theta, multiplied it by the radius, and that gave us an arc length. So there's our formula. Theta times r equals S. Usually that's expressed as S equals r theta. You could of course solve for theta F theta equals S over R, or solve for R equals S over theta. So it's a formula that allows us to find quite a bit, either an arc length, a radius, or an angle theta measured in radians. The formula doesn't work if you don't have radians. What percentage of a circle's circumference is cut off by an angle that is 35 degrees plus 1.5 radians? Illustrate this angle measure below. So the first thing I think of when I read this is that we have some angle. I'm just going to draw it like the last problem. And then that angle equals 35 degrees plus 1.5 radians. Now, I don't really like having the angle with two different units, but I know that I can convert 35 degrees to radians because I know that in 180 degrees there are pi radians. Computing that, get something close to 2.11 radians. So what this tells me is if this is my radius of the circle R, then this arc length S equals to 2.11 times R. There's 2.11 radii here. Now, we want the percentage of the circle's circumference that is cut off by that angle. Now, the circle's circumference is 2 times pi times the radius. And if we want a percent, we just take a fraction. The total is our denominator, and then the part of our circumference cut off is 2.11 r. We can simplify this. R divided by r is 1, so those cancel out. 2.11 over 2 pi. We get 0.335817, or about 33.6%. The book has an interesting alternative solution. They noted that we could cut off this piece of the angle, that's 35 degrees. This other one right here is 1.5 radians. Now 35 degrees cuts off 35 over 360 degrees. That fraction of the circle is this this cutoff here, the circle circumference. And then here 1.5 radians out of a total of 2 pi all the way around. That gives us the fraction cut off right here, and if we add those together we get the same result. A fellow student announced that the measure of the given angle is 1.2 inches. Is this an appropriate measure? Why or why not? Well, clearly no. Angles are measured in radians or degrees. The 1.2 inches is the measure of the arc length. Also, note that it's not appropriate to say the angle measure is 1.2 inches, because while that measurement may work to describe an angle of circle corresponding to this size, but if we increase the size of our circle, notice that the angle would stay the same, but this length would get bigger. So we need a different measurement for the angle than inches. Use the given illustrations to answer the following question. A circle has a radius of 12 inches. An angle whose vertex is at the center circle cuts the circle into two parts, with one part measuring 3 pi over 2 radians. How many inches is the arc length of that part of the circle? The easy thing that you can do is use the equation S equals r theta. The arc length equals the radius times the angle measured in radians. We have our radius of 12 inches, and we have our arc length, our angle measure, 3 pi over 2 radians. Multiply those together. 12 over 2 is 6, times 3 is 18 pi inches, and we probably don't want to leave the pi in there since we're talking about inches, so 18 times pi. So about 56.5 inches. A circle has a radius of r inches. An angle whose vertex is at the circle's center cuts off s inches of the circle's circumference as the terminal side of the angle opens in a counterclockwise direction from the initial side of the angle. Write a formula that conveys the relationship between the radius length r measured in inches and the angle measure theta and the arc length s. Well, this is what we did before. S equals r theta. Ta-da! A circle has a radius of 4.8 inches. An angle whose vertex is at the circle's center cuts the circle into two parts, one part measuring 19.6 inches. What is the measure of this angle in radians? So we can use our formula. This is sometimes called the arc length formula, S equals r theta. This time we're looking for theta, so we can divide both sides by r. Have S over r equals theta. Just substitute some numbers here. The arc length is 19.6 inches. And the radius is 4.8 inches. And that's about 4.0833 inches. For questions 5 and 6, imagine a bug sitting on the end of a fan blade as the blade rotates in a counterclockwise direction. The bug is 2.6 feet from the center of the fan and is located at the 3 o'clock position as the blade begins to turn. If the bug travels 5.2 feet around the circumference of the circle from the 3 o'clock position, what angle measure has been swept out? So here just imagine that the bug's moving. So let's imagine that this bug moves in circular motion around the fan, kind of like this. Nope, not like that. This circle will trace the trajectory of the bug's motion. And we only want 5.2 feet of the circle to be swept out. So essentially the bug starts here and he goes around this circle until about 5.2 feet have been covered. So then we want to know what is the angle measure that has been swept out. I'm just going to draw that angle. Here's our angle right here. Notice that we have an arc length, S. We have a radius, 2.6 feet. And we're just looking for our angle theta. And we know that S equals r theta. where theta is measured in radians. And so S over R equals theta. That means theta equals 5.2 feet over 2.6 feet which is 2 radians. If the bug travels 11.7 feet around the circumference of the circle from the 3 o'clock position, what angle measure has been swept out? Again, we just do the same thing. Theta equals S over R. The arc length is 11.7. feet, and the radius is 2.6 feet. That gives us 4.5 radians. Part C, express the angle theta, angle measure theta in radians swept out by the fan blade in terms of the arc length traveled by the bug S and the circle's radius R. So we already see above that theta equals S over R. If theta remains the same and the radius of the fan doubles, how will the arc length change? Well, instead of having an R down here, you'd have a 2R, but we want to know how the arc length would change. Notice that we could multiply both sides by 2R and have theta times 2R equals S, which equals 2 times theta times R. And so basically, if the radius of the fan doubled, then the arc length would double also. Number 6. How many feet has the bug traveled around the circle swept out by the tip of the fan blade when the angle swept out by the fan blade is 0.765 radians? Or pi over 2 radians. So here we're just given theta, and we need to find the arc length. So using S equals theta R, we can just substitute 7.65 radians and our radius of 2.6 feet. We get 1.989 feet. We can do the same thing with the second calculation, just pi over 2 radians. The radius R, 2.6 feet. Multiplying those together gives us 4.084 feet.